We can ask, how can a structure be older than our universe? Is the Big Bang Theory wrong? Join us as we explore how the James Webb Telescope discovered a 13.8 billion year old structure and its far-reaching implications. Imagine looking into a vast cosmic world where stars and galaxies dance a brilliant dance of light and gravity, revealing the secrets of the past and the future. This is what the amazing space probe, the James Webb Space Telescope, does every day: captures and transmits amazing observations to Earth. It recently revealed a mysterious sight, a 13.8 billion year old celestial structure that defies the foundations of our cosmic understanding. Through this remarkable technological marvel, we are exposed to a deep cosmic mystery intricately woven into the fabric of the cosmos itself. This shocking discovery has sparked a firestorm of debate and explanation in the scientific community as they try to unravel the paradox of this ancient structure. Famous scientists and prominent observatories around the world are constantly filled with questions about this mysterious phenomenon. The most popular of these questions is, how can the James Webb Telescope detect a structure older than the universe itself? To answer this question, we must first zoom in on this structure. It's not a galaxy, a nebula, or a black hole. It's a star, a very old and very special star, more than 200 light-years away in the constellation of Libra. It's called HD 140283, but it has a more appropriate name: the Star of Methuselah, after the biblical figure who lived 969 years. This star is not only ancient, but also fast, zooming through space at more than 800,000 kilometers per hour, revealing its dramatic history some 12 billion years ago, when our Milky Way progenitor swallowed the dwarf galaxy that was its original home galaxy. However, it is not speed, but age that makes Methuselah's star truly fascinating. It is one of the oldest celestial bodies we have ever observed, and its age defies logic. The age of the star was originally estimated to be about 16 billion years, but the most recent estimate is 14.46 billion years, with an uncertainty of 0.8 billion years. This number is a mystery because the age of the universe, determined by observations of the cosmic microwave background, is about 13.8 billion years. How can a star be older than the universe itself? It seems impossible. This paradox has given rise to questions about the age of the star, the age of the universe, or the accuracy of dating methods. Could the star be a remnant of a previous universe? Could the universe be older than we think? Could our dating methods be flawed? Let's explore these options in more detail. First, we must understand that measuring the ages of celestial bodies is a daunting task. Stars like the Sun maintain their brightness, temperature, and size over billions of years, making age estimation difficult. Astronomers rely on subtle changes in brightness and color over time, and compare these measurements to mathematical models that predict how stars change with age. One key indicator of a star's age is its rotation rate. Over time, stars slow their rotation, like a wheel slows down due to friction. By comparing the rotation rates of stars of different ages, astronomers created mathematical relationships to estimate their ages, a method called gyrochronology. Another indicator of a star's age is its magnetic activity. Magnetic activity, such as flares and bursts of energy on a star's surface, decreases as a star ages. Astronomers have developed advanced techniques, such as astroseismology, to study vibrations on the surface of a star caused by waves traveling through its interior. These oscillations change with the age of the star, helping to more accurately estimate its age. Using this method, astronomers, for example, have estimated the age of the Sun to be approximately 4.58 billion years. Returning to the Star of Methuselah, astronomers determined its ancient age by considering the number of stars to which it belongs. Stars in the universe can be classified according to the amount of heavy elements or metals they contain. Our Sun is a population 1 star with a significant amount of heavy elements. In contrast, Methuselah is a population 2 star with less heavy elements, especially iron. This means that the star was born before most of the heavy elements in the universe were born, which happened in the explosions of massive stars called supernovae. There is also a hypothetical class of stars called population 3 stars, which are thought to have almost no heavy elements. Those stars are probably the first to form in the primordial universe shortly after the Big Bang. They were very massive and hot and burned their fuel very quickly, turning hydrogen and helium into heavier elements. When they die, they explode as a supernova, scattering some of those elements into the surrounding space. Population 2 stars were born from gas clouds lightly contaminated with these elements, while Population 1 stars were born from gas clouds enriched by later supernovae. The existence of Methuselah's star raises a puzzling question. How can it be older than the universe itself? The answer is not simple because it involves a lot of uncertainty and assumptions. Based on measurements from the Hubble Space Telescope, there is a 70% chance that Methuselah's age varies between 13.66 and 15.26 billion years. However, there is also a 30% chance that the star's age is outside this range, and a 15% chance that it is even lower. All factors considered, there is at least a 20% chance that the actual age of the star is younger than the age of the universe. This is like rolling a regular six-sided die and getting a 6, which is not very unlikely, but it also assumes that there are no other sources of error or bias in the age estimate. However, it is undeniable that the star of Methuselah is incredibly ancient. In fact, it is the oldest star in the universe whose age can be determined quite accurately. Instead of asking if it could be more than 2 billion years older than its surroundings, we can approach the problem from another angle. Could the universe be as young as scientists first thought? In fact, the enormity of 13.8 billion years is hard to grasp. If you were to plug the entire history of the universe into a cosmic calendar, where the Big Bang would be the brightest New Year's fireworks, the Earth wouldn't appear until late December, and recorded human history would only cover the last 10 seconds of December. 31. Scientists calculated the age of the universe by observing the light of stars born only a few 100 million years after the Big Bang. As the universe expands, it stretches this primordial light, making it redder, called redshift. By measuring both the distance and redshift of these stars, scientists can infer the age of the universe. However, recent findings by researchers from the University of Ottawa suggest that the universe may be much older. They thought it might be about 26.7 billion years old. Rajendra Gupta, professor of physics at the University of Ottawa, points to an old theory by Swiss astronomer Fritz Zwicky that dates back to 1929. This theory claims that photons lose energy when they travel large distances in time. This contradicts the observed redshift data, but Gupta argues that by accepting this theory along with an expanding universe, we can see the redshift as a mixed phenomenon that is not due to expansion alone. Extending the age of the universe may shed light on some long-standing cosmological mysteries, as well as new ones revealed by NASA's James Webb Space Telescope. Gupta arrives at an age of 26.7 billion years, combining tired light theory with the idea of developing coupling constants, first proposed by theoretical physicist Paul Dirac, meaning that the interactions between particles could be changed over time.
It is important to note that scientists have changed their estimates of the age of the universe in the past. For example, in the 1920s, Edwin Hubble thought that the universe was only 2 billion years old. However, our methods have become more accurate over time, and doubling the age of the universe is a huge leap. It's still unclear whether astronomers will change their minds about the age of the universe based on Gupta's work, but whether the recorded history of humanity lasts only 10 seconds or 5 seconds on the grand scale of the universe, one thing is certain. The universe is old and wonderful place. If we focus on the age of the universe, there are some fascinating observations about the Milky Way. Recent measurements show that stars at the edge of our galaxy move much more slowly than stars in similar locations in other galaxies. There are a number of possible reasons for this phenomenon. One is that our galaxy may have very little dark matter, the invisible substance that affects the gravitational structure of cosmic objects. Another possibility is that our knowledge of dark matter, including how much of it there is in the universe, could be completely wrong. This puzzle comes from data collected by the European Space Agency's Gaia satellite, which provides detailed information about the velocities and positions of nearly 2 billion stars in the Milky Way. These precise measurements made astronomers reconsider their assessment of the behavior of stars in the galaxy. Several research groups have found that stars orbiting the outer disk of the Milky Way, about 880,000 light-years from the center of the galaxy, move at an average speed of 167 kilometers per second. This is much slower than expected and challenges our understanding of galaxy dynamics. The mystery of Methuselah's star and exciting discoveries about the outermost stars of the Milky Way are opening new frontiers in our quest to understand the universe. As we delve into these mysteries, we are reminded of the vastness and complexity of space, a realm where every discovery leads to new questions and every answer reveals a new layer of wonder.